What's up, guys, and welcome back to another podcast here on the ArchiTech network. Today, we have a special podcast. I've had a few people ask me about what I've been doing since I left Big. For those of you who don't know, I went to join FACIT Homes. So I thought, what better way to explain to people than to get on our founder, Bruce Bell. And we're going to be talking to Bruce about the origins of FACIT Homes, how they got started, his background as an industrial designer to now building sustainable homes. We'll also be touching on the landscape of house building in the UK right now, modern methods of construction, the failure of traditional and also factory-based is a really interesting landscape that we sit in right now. And of course, we'll touch on the work that we've been doing at FACIT in this new era of upscaling our technology. So we're going to be touching on all of this with Bruce. As always, though, if you like this episode, give us a like and a subscribe. The more that we can grow the channel, the bigger the guests we can get on. And thank you for everyone that supported us to get to 10K so far. It's a milestone. It's a huge milestone for us. So thank you for your support. But without any further ado, let's jump into it and have a chat with Bruce. Okay. All right, we're live. Welcome to the podcast, Bruce. Great to have you on here.
Thanks for having me. Excited.
Yeah, this is a unique one. It's the first time I've had my live boss on, so I think this I'll be careful what I say, but
Yes.
but yeah, I think it's actually a great time to have you on because I've had a lot of people ask me what I'm doing at FACIT, and I think this is a cool way to show people a little bit about what we're doing.
Yeah.
But yeah, maybe to give the audience a bit more of an introduction than what I gave earlier. You're obviously the CEO of FACIT Homes,
Yeah.
and which you started kind of around 2007.
hmm
But before that, you had this quite interesting background in industrial design. You went to the Royal College of Arts.
Yeah.
You worked for a little bit for various kind of artists, including Anthony Gormley's studio. And then you kind of made this transition into Foster and Partners,
hmm
and then went on to found FACIT, which I think is kind of a quite an interesting background. Is there anything key I missed? But
I think you've captured most of it. But yeah, that kind of background in industrial design and learning about architecture and then that kind of digital fabrication side is really um, what I'm about.
yeah, so maybe it's a good place to start with like the origin stories of
Yeah.
FACIT, because I think one of the interesting things about FACIT is we've been innovating in the housing space for a while now. It's and you've almost been like a little bit ahead of the game on this kind of stuff.
Yeah.
Talk us through the origin stories, going from Foster's and starting FACIT Homes.
Yeah. So before Foster and Partners, I actually studied industrial design. I've always had a kind of fascination for architecture. So that kind of mixture of like product design, manufacturing, and then a kind of just an interest in architecture. I think if I had had the qualifications, I might have studied architecture, but I didn't. That wasn't me. So like straight out of uni, I landed at Foster and Partners back in like 1999, and I actually joined the edge of a visualization team, but I quite quickly moved into design development. So I was working on competitions and doing bits of like visualization and development work, kind of taking on early stage schemes and fleshing them out and working with the design teams and getting them ready for submission. So I saw like loads of really interesting projects, like maybe 30 different projects whilst I was there. And specifically, there was one project that I worked on, which was the Casa Futura, which is Italian for House of the Future, which is a house high up in St. Moritz in Switzerland, kind of ski town. And it was working with the advanced geometry team at Foster and Partners, which was Hugh Whitehead and Judith and Francis Ayesh. And I kind of got to see that kind of early stages of what has become computational design. So working with complex geometry, generative components, and so the building was kind of curved and looked like a kind of kidney bean on legs, and it was digitally fabricated glulam timber beams It was really precisely made steelwork, and but also had a kind of handmade kind of craft element to it as well. So there was a lot of timber shingles which were made by hand, and it was just a really interesting kind of uh, opened my eyes really to a very different way of what architecture could be, particularly in terms of the use of computers, which is really my strong point. Is like I'm a really proficient software user. 3D is me, anything kind of 3D and computers is something that I gravitate to. So that was the beginnings of like, wow, this is interesting. And then after I left the RCA, I wanted to kind of get focused on being very hands-on. So sorry, after I left Foster and Partners, I went to the Royal College of Art, the RCA, to get quite hands-on, but also to use digital technologies. So I knew from my industrial design background that there's a lot of digital fabrication techniques out in the world, from laser cutting, routing, wire bending, tube laser, like there's all these things which I knew about. So when I landed at the Royal College of Art, I started like actually accessing these tools out in the world, as well as a bit of 3D printing in-house at the RCA, but just experimenting with these technologies with a kind of idea of what architecture could be. So that kind of really proved the point that this technology existed. It was very accessible, it was very cheap, and could somehow be used for architecture. So after the Royal College of Art, I kind of went into a very traditional practice. Like I set up with some guys that I met at Foster and Partners, small practice, really starting right at the bottom. I thought they knew what they were doing, but they knew as much as I did, which was very little. And we ran a practice for like 5 years, and it was really hard work, and we didn't really get that far. I learned a lot about what not to do. We were, we're building these houses and giving contractors design information, and just trying to get them to build it was such a headache. And I was like, God Almighty, there must be a better way of doing this, because we're designing everything on computer. We're putting all of our love into this design work. We're giving it to contractors, and then we're trying to push them to build it. And I had seen, I know we can use a computer to make something. So at that point, the kind of thing started to kind of solidify, and we got some research funding from what was the Greater London Authority to kind of develop ideas around digital craftsmanship was actually the title of the research project. And I had two different sets of funding, and that kind of resulted in a kind of proof of concept. And the chosen technology at that time was CNC routing, right? Really common furniture grade routing, because I thought it was very accessible, very cheap. We managed to buy a machine and get our hands on, and really start to kind of understand it, develop some working methodologies around it. And we kind of proved it. We kind of built the first full-scale prototype, and we started, kind of going, actually, there's definitely something here. We've shown that we can do this. And at that point, it was like, oh, I think I should probably do this. So I kind of moved on from the architecture practice and said, no, I'm going to try and get this off the ground. So that was back in 2007. Where we had our first proof of concept. And then we did a few kind of exhibition builds in 2008. And then it took a little while to kind of get real customers, to go and say, right, we're going to build some houses, actual real houses for real people, get out there and try and find people who wanted to build houses, who were willing to work with us, and get the first projects off the ground. And at that point, we were still really feeling our way through, like we'd managed to find a machine that we could buy, and we set up a side business to pay for the machine. So we were providing CNC cutting services, and we were starting to just get into Revit. That's the kind of first stage I was really starting to understand Revit as a tool of what it could potentially do, and also start to build some, like the first stuff that we built from for the proof of concept was really rudimentary. It was built in 3D Studio Max, but I had this way of working where I could like build the component in 3D and flat pan it, and it's still parametric. Like somehow I managed to get the kind of just work the software to do what we wanted, but it was pretty sketchy, but it worked. And after that, it's like, right, okay, come on, well, how do we do this properly? What are the software tools that we need? How can we leverage Revit, and just starting to kind of build it into um, more of an actual business, I guess.
Was that first proof of concept that sort of like what looked like a pavilion where it was like, half a building, two
Yes,
stories thing?
exactly. So it was
Yeah.
two-story kind of concept of a part of a section of a building. Yeah, and that was at the Architecture Foundation. We built that. They had a space on Old Street, and we had a big opening, and yeah, and it was really, it created a lot of interest. Um, so yeah, that was really a good start for us. But actually going from there to building some houses, that's quite a challenge, finding
Yeah.
somebody who's willing, and actually getting planning permission and doing costing and doing the really brutal reality of turning what is just a bare idea into a real house for a real client, was a huge challenge.
Yeah. Yeah. I mean, that's we'll jump back to some of those tricky things of actually building homes, which is kind of the less sexy side, but the critical side, right?
Mm.
Of actually building stuff for people.
Yeah,
It's amazing. So that first proof of concept you made in 3ds Max
yeah.
at that time,
Yeah.
that's cool. I didn't know that.
Yeah, it was pretty cool. And there was like quite a few different components that we built, and I knew that somehow you had to have this relationship between the build component or the kind of upright, in situ component and its flat pattern version. You had to be able to adjust the thing and also dynamically adjust all the parts as well. So that was kind of baked in from the beginning, just in quite a maybe an unusual way.
Yeah, yeah. So let's fast forward to today. Over the last kind of 10, well, since 2007. Well, I guess that was a few years after that. But what are we doing now? What is Facet Homes doing, in terms of delivering housing?
Yeah, so so
And also the key thing, how are we doing it? Because
So yeah, okay. So now FACIT Homes is a home manufacturer. So we design, manufacture, build homes for private clients, right? So we do at the moment we're purely focused on private client work, but we're expanding into developer kind of larger scale projects. But the core business at the moment is building one-off homes. So usually quite large properties. They're quite high end, but they're not crazy fancy. And customer comes to us and we do everything. So we literally do everything from concept design, planning permission, construction management. I've got a team, a kind of collaborative team in the studio who is um, a mixture: architects, production engineers, construction management, order management, and like quite a broad base for the team who work side by side. So there's no kind of separation in terms of this business. Everybody works collaboratively, and that's kind of the key to what we do, is thinking about the house as a whole, as a single entity, as not as a kind of fragmented um, uh, product, which is quite often what happens in construction. So we take the whole thing on for the customer and we deliver everything. So we're thinking about the whole delivery, the groundworks, the civil infrastructure, the manufacturing, the finishing, the construction, like literally everything, and trying to kind of piece everything together and build processes around that to deliver great homes. So at the moment last year we built six quite large properties, reasonably high end, and we're growing quite quickly. We're doing kind of more and more of that client stuff, but we're also starting to engage more heavily with developers, and looking at kind of larger scale housing schemes.
yeah, and no, I think it's been definitely interesting being in the office over the last few months and seeing the like spectrum of, I'm maybe playing with a script to make the chassis, but at the other end of the office, something is delayed because of delivery for whatever reason, and then you have to like shift these things around. So it's like
Yeah,
you got the complete ends of the spectrum in one office.
yeah, exactly. And we have to deal with the brutal reality of construction. And we're constantly saying to ourselves, how can we improve construction processes? How can we transform traditional processes with digital technology? How can we transform analog processes or make analog processes as digital as possible? So it's a
Right.
huge challenge because you've got so many variables from time, quality, there's a obviously a huge human element. No matter how much digital fabrication work you do, you've still got humans putting things together, and you've still got people doing finishing work. So we see all of this through the business, and we're focused on delivering the best possible homes we can, and trying to deliver architecture. We're part of what we want to do is build really good homes, right? Not just kind of smash out noddy boxes. We're really focused on how digital technology can deliver beautiful buildings, interesting designs, architecture, detailing. That's really the power we think of the kind of digital manufacturing side, is that the seamlessness of which you can deliver complex, interesting designs and guarantee that it's going to be right, and you don't have that kind of unknown factor of, is my contractor going to be capable of delivering this
Yeah.
kind of level of complexity? And the power of the digital fabrication, it just guarantees it. It just says, we know exactly this process. We know the engagement of the cutter to the timber, or the laser cutter to the steel, whatever it is. We know that level of detail, and that guarantee that comes with an advanced manufacturing process, and how we leverage that beyond the component itself. So we're quite focused on, we'll use digital manufacturing to make components, but how can that influence the next stages? How can that de-risk the follow-on stages? So we quite often make things that are more complex to resolve more problems down the road, as opposed to just a very simplified version of construction.
Yeah. Yeah, no, so like the key thing with Facet, as you said, is we're trying to digitize as much of the design to construction process as possible. And there's a few, maybe we can expand on a few of the key ways I explain it, like some of the key things. BIM to manufacture, we can maybe jump into that. Of course, the FACIT chassis and the FACIT components is like the backbone of each of our houses. And of course, I think the other super pioneering thing is where we build with our mobile production facility and our
Yeah.
micro factories. Maybe expand on that.
Yeah.
What is
Okay.
BIM
So
to
what I
manufacture?
would
And
start with is the first kind of principle that we have is, think of the building as a whole thing, right? So
yeah,
think of it as one entity. So for us, that means every house has got the same constituent parts. So every house has got the same foundation system, the same windows, same door set, same heating, and in the middle, the same kind of underlying superstructure, which I'll talk about in a minute, which we call the FACIT chassis. Um, and the way that we get there is by leveraging building information modeling as much as possible, as a kind of start point, as our main design tool. So we use Autodesk Revit as our main principal tool. But what we've done is we've built a commercial model around it as much as anything. So what we quite often see in the sector as a whole is architects not being particularly incentivized to create really good models or good families or good digital assets, because it's not really what they're paid to do. They don't get any benefit from it. So you quite often see uh, BIM models being handed over to contractors, and then the contractors kind of trying to figure out what to do with it. And it never really gets to that level of capability which we know the BIM has. So whereas what we do is we invest really heavily into BIM assets. So we'll spend $20,000 on a single digital asset. So let's say it's a window. We'll really invest heavily into that digital asset, and then we'll leverage it through our manufacturing process. And that's where we get the benefit from it and the return on the investment. So we produce what we call engineering grade BIM, which is like every single feature, absolute tolerances, information that's fit to go direct into manufacture, because that's what we're going to do. We're going to take the BIM model, and we're literally going to go straight from that into manufacture, and whatever is in that BIM model is literally going to come out the other end of our manufacturing process. So you have to really focus on building really good quality, well coordinated, well resolved BIM information. And so from that, we've then built this kind of back end process to do the fabrication work for what we call the FACIT chassis. So the FACIT chassis sits in the middle of every house, and like the chassis of a car, it's more than a frame. It's ready for services and penetrations, and it's avoiding that kind of rework that you get on building sites, where quite often like particularly with timber, you get like a stick frame, put the stick frame up, and then you get that up, and then one guy will push the insulation in, another one will pull it out and chase and run a cable, and there's a lot of reworking, right? And that's where you get a degradation in quality, or at least a very big variance. Um, so our chassis is not only is it much more ready for the other parts to go onto it and kind of defining where they go. So, for example, it will mean it's ready for the roofing membrane to go on. The roofing membrane will go on straight onto it, and the plasterboard will go straight onto it, and everything is, ready to just fit the other bits on, and there's not that layering. So think just simple things like let's not produce a batten cavity for the inside for services. Let's just make sure it's ready. Let's make it include ventilated cavities for falls for drainage, and all the kind of fiddly stuff that you get around the perimeter of the roof. And actually, let's include the staircase, and let's include the window interfaces, and let's include the door portals and the back sets for the plumbing, and like as much as possible. So it's kind of like this multi-product um, chassis, which would, if you look at a traditional home, it would normally be lots of different building processes or building products. So one product for the walls, one product for the floor, one for the roof, another one for the internal stud work, another one for the staircase. And so rather than all being separate, we squeeze them all through this single digital funnel so that we can then get the efficiencies, get the use out of the manufacturing process, and get the accuracy and all the other benefits through it. So we're really incentivized to say, well, could we make that? Could we put this through this same process? How much can we do? And that's the kind of FACIT chassis. And then we'll try and leverage the same process for other kind of finished products. So metalwork for staircases, cladding panels, whatever it is we can do. And as we go, we try and digitize more and more and more. At the moment, we're maybe 65% of the property is digitally fabricated. Over time, we want to increase that and see how far we can get. Because every time we digitally fabricate something, we resolve a problem. And every time we finish something by hand, and we're reliant on the skill of the person or the interpretation of a drawing is always where it goes wrong. But
Yeah.
um, so that's the kind of like the actual product. But in terms to get to that product, we have our manufacturing process, which is focused around CNC routing, which is a compute-controlled three-axis spinning cutter. And we built ourselves our mobile production facility. So most kind of manufacturing process, people are like, oh, you manufacture homes, so you've got a factory. And we're like,
Yeah.
no, we don't have a factory. People are like, how does that work? And what we've ended up with is bringing digital technology onto the building site. And people will be like, why would you do that? And actually, there's so many reasons. So we've tried manufacturing on site and we've tried manufacturing off site. In fact, for several years, we were producing in a factory and shipping. The advantages of fabrication on site are huge. The principal point is inventory, right? So inventory is you're holding on to either materials or a thing, a stock, a component, and how long do you hold on to that before it's in its final position and it's billable or chargeable or however you want to think about it. And the longer you hold on to things, the more inventory you have, the more difficult your business is to run, right? So the beautiful thing that happens on site is you bring your machine, you drop it down on site, you turn it on, you start manufacturing, and you make something. Your material comes directly from the dock side onto the building site. You make it into something bigger, but you immediately install it. So you're literally reducing the time from manufacture to install to the absolute minimum. It's about as lean as you possibly can be. And manufacturing on demand actually looks quite traditional in some ways. The reason that homes are built traditionally on site, or the majority of them are, is because there's a simplicity to it, which is, oh, I'm going to make things when it's required. I'm going to kind of just work my way through this project, and actually there's a lot of advantages in that because you're not having to deal with complex supply chains and variables. I mean, particularly in construction, there's just so many variables, right? From planning conditions to site access to labor force to weather. There's just hundreds of variables, and it's the variables that really make it difficult to do really advanced offsite fabrication, where you're so reliant on everything happening in the right sequence, and invariably something doesn't turn up, on the right time. And you see this happening as much in the factory as you do on a building site. In a factory, your windows are still going to arrive at the right time, but you're producing that much further in advance that it becomes more and more and more problematic if your windows don't
Yeah.
turn up. Whereas for us, we're focused on being incredibly agile, right? So a lot of the kind of technology that we use allows us to be really flexible, reactive. There's a problem on site, right? Or a component that doesn't work. Okay, we'll modify it and react to that. Um, we're minimizing the cost risk as well. So there's so many advantages to it. And it's just a really amazing process. It's compact, it turns up, you turn it on, machine starts running, you're cutting things, putting it in the building. It's really simple, and actually even the training is simple. So we'll train a new team in 3 days from scratch, never touch the machine, know nothing, and that is to operate the machine, which is super simple, but also to assemble the components with our instructions, right? So there's again, kind of simplicity. The complexity is managed in the studio, in terms of the component design and the cut lists and feeding of information into the machine, which we do from the studio. Whereas the actual site activities are quite straightforward. You're still buying into kind of like, fairly traditional carpentry, but it's more, actually the carpenters who erect the frames, we're really leveraging their experience of setting out more than, how they can make a mortise and tenon joint.
Yeah. Yeah, no, I think there's so many advantages to that on-site construction. I guess it's touching into that lean manufacturing that, for example, like Toyota are very much into. I think your example of, yeah, if for whatever reason your window is delivered and is slightly the wrong size, it's much easier. We can just cut a new component and replace it. So I think this on-site hybrid approach is obviously something that I feel you pioneered at FACIT, and you've been doing it for some time now. It's you've kind of perfected that. Bring it on, unfold it, um, micro factory.
So the other advantage though of the on-site manufacturing is just the sheer flexibility that allows you in terms of design. Like actually at the opposite end of the extreme, you've got factory produced volumetric homes, which are basically building whole rooms in a factory. And you're so constrained. You basically, everything has to be shipping container size because that's all you can fit on the back of a truck. And there is only so many variations that you can achieve with that. Whereas this system, because the fabrication work is done on site, there is zero shipping constraints, and also just the inherent flexibility in the manufacturing process literally means we can build anything. So we can build
Yeah,
any shape of house, any size, low rise, 4 stories, semi-detached, detached, terraces, all through the same digital process because it is a process, not a it's more of a process than a building system. There's a systemized element to it, but it's much more philosophical and digital than it is physical.
yeah, yeah. It's also fairly low cost than building a giant factory,
Oh yeah, absolutely.
right?
I mean, the typical cost for factory setup at the moment. So if you look at someone like Top Hat or Legal and General, both of which have stopped, they spent between 150 and 200 million pounds on their
Yeah,
factories, and it's just
yeah,
such an asset. So those companies are putting their money into physical assets, which are very they're just massive baggage. They have huge downsides to them, and actually is the reason why they've stopped functioning as
yeah,
businesses. Whereas if you focus your money into digital assets with really flexible end tools that are really low capital costs, it's just a completely different way of working. It's completely turning the world on its head.
yeah. We'll delve on into that in a second, but just give people an overview, like the broad benefits of using Facet to build your home versus traditional. Obviously, the speed of construction, like you were saying, getting to site is actually much quicker, and generally the cost is fairly competitive with traditional, right?
Yeah, I mean, there's lots of different benefits. So I think the principal benefit is that responsibility. So one of the things, yeah, coming back to my training, right, industrial design training. If you look at how most industrial design companies work, right, when I say industrial design, I mean manufacturing companies. So let's say Apple, or let's say a bicycle manufacturer is quite a good example, right? Bicycle manufacturer, typically they'll manufacture the frame themselves and they'll buy in components from SRAM or Shimano or whoever, but they guarantee the thing will work as a whole and they sell it to the customer. That's their guarantee is quality. You trust in the brand, you buy the product, great. And then, I was working in a small practice doing traditional contracts where you've got um, such a fragmented kind of design and construction process
Right.
where you've got an architect designing something, you've got a builder over there, and you can't just from a really first principles point, you say, who's in charge? Like the
Yeah.
customer is paying the builder directly. So the builder's kind of aligned with the customer. The architect's slightly adjacent, kind of in charge, but not really. They're not really a project manager. Just the whole kind of everything around it that I just thought, this is not good for the customer. I didn't think it was a very good customer experience. I thought that it just made them anxious and it was risky, because of that kind of there was nobody in charge, no one party taking responsibility. So the thing that I thought is, see, what customers want is they want somebody to just take the whole thing on, right? And say, this
Yeah.
is how much it's going to cost. This is going to work. So that's the first thing that we do is, it's just a whole brand and we take absolute responsibility and we deliver for the customer. Um, but then the other advantages are you're not starting again every time. The fact that we know our products inside out and we're building basically the same house over and over and over again in different variations means that we refine and refine and refine both the design, the interfaces, the construction management, the supply chain. It just gets better and better and better over time. So now we're at a point, if you compare it against a traditional construction process, it's definitely cheaper, it's much better customer experience. The quality's there, the guarantees are there. Just overall, it's just like light years away from a traditional construction process where you never quite know what the outcome's going to be. Um, and then on the speed thing, I think a lot of people don't recognize that speed is the overall thing, right? Which is how long does it take to design? How long does it take to get planning permission? Actually, that bit for us is not that much different from a traditional process, but how long does it take to get the design information together and get it out to tender and get your building contractor to price it and agree and mobilize and then realize, oh, it's too expensive, and then you've got to redesign and reprice. And honestly, that adds years onto projects.
Yeah.
The thing where not only is our build process very streamlined and quick, we'll build in about half the time of a traditional contractor, but that bit before it, which is often as long. Honestly, the bit between getting planning permission and build can often be 12 months plus, and we'll chop it down to 3 months. So I think that people can get quite carried away with ideas, or even like prefabricated buildings, right? So people see one of our German competitors is a good example. They'll see their properties go up in 3 days, but actually they've waited a year to get it out of the factory. It goes up in actually
Yeah.
3 weeks, and then it takes 3 months to fit it out because it still doesn't have the floor finishes, it still doesn't have the kitchen, it still has all the joints and decoration to do. So the overall is still longer than it takes us to do it. So I think that people are very seduced by ideas of speed as opposed to the brutal reality, which is, well, how long did it actually take?
Yeah.
So
Yeah.
we kind of win on all fronts. So yeah, it is a much better experience for customers, and our customers, we have very professional relationships with them. I think the other thing for them is they don't have to work with a builder. Well, it's funny, actually, the funny thing about the business is there's nobody in the business from a construction background, not one person.
Yeah.
Everybody's from engineering, finance, architecture. Nobody's actually a builder of any description or run a project or anything, but we make it work, and we do better than the traditional competition.
Yeah. Yeah, no, we've definitely got a mix of different backgrounds. I think that's what kind of makes it interesting is all these different disciplines coming together. Um, Maybe let's touch on that landscape that we kind of touched on a little bit of the landscape of house building right now,
Hmm.
right? You've got on one end traditional, which is, your classic builder with breeze blocks and cement, which is currently also going through a crisis and increased labor costs. And then at the other end of the spectrum, as you've also touched on, you've got like the factory-based, the volumetric, the panelized. This is where you've seen that story of build a big factory and we're going to pump houses out. You know, materials go in, house comes out, almost like car manufacturing. And it's also proving not to work. I mean, it seems like on a weekly basis we see them uh, folding. Yeah, give us an overview. Why are these not working, and set up the landscape for housing right now?
Yeah, so the big picture is the underlying change in everything is labor related. So you've got a lot of change in the labor force. So the labor force is getting older. Um, Specialist skill people like bricklayers, for example, are retiring. The younger generation just they don't want to be bricklayers, right? And so they're not becoming bricklayers because it doesn't seem like a very appealing job. And a lot of them are getting educated and you know they're coming out with degrees and like if you've got a degree, do you want to be a bricklayer? Probably not. Um, but then the other side of the labor thing is the house building sector in particular is incredibly reliant on low skilled labor. You know,
Yeah.
it's kind of part and parcel of how it operates. And low skilled labor means people hoiking stuff around, you know, just moving bricks and blocks and tidying up. And so the low skilled labor used to be really cheap, and now there's a shortage and it's got really expensive. So we've moved from paying people low wages to do crappy jobs to now paying people high wages to do the crappy jobs because they're crappy, and people don't want to do it because they've got choice. So that's the kind of main driving factor in the change. And it's only really just starting to bite, I think, is the reality. So the house builders and home sector is starting to change, and people have known about this for a while, that these big changes in labor force are coming through. So there's been a big move to try out different ways of working. So there was a big critical report written in 2015, 16, the Mark Farmer report called Modernize or Die. And that kind of pointed everybody towards offsite fabrication as a kind of way of mitigating this problem that was looming. So you've seen some really big organizations put a lot of money into this area. So you have Legal and General, Top Hat, Splash Modular, Swan Housing. There's about 5 or 6 big companies who all of them invested hundreds of millions of pounds each.
Yeah, a lot of money.
Like an insane amount of money, and it hasn't worked. So we've seen over the last 2 years, pretty much all of them go bust. Pretty much every single one. Legal in General being the biggest failure, they lost, I don't know, like 350 million pounds. You know, that's a huge loss. So between these 6, 7 companies, they've lost about nearly 900 million pounds. I mean, it's an
Right.
insane amount of loss. And
Yeah.
the really disappointing thing is we've not got much residual value from it because a lot of it went into physical infrastructure. So just building a huge factory, building a very old school kind of physical production line, like just stuff, physical stuff to move things across. That's where most of the money went. And those that tried to automate just couldn't, it's just so expensive to really automate. So quite often they're still quite rudimentary. So, you know, they've tried this kind of new way of working. I mean, actually, interestingly, philosophically, what they were trying to do is build the home as a product, which is very much where we are. I think there is some, you know, really interesting and good things where actually you're saying, right, home as a product, single company is going to take responsibility for it and deliver it on behalf of the developer or whoever it is. But that model just hasn't worked because it's such a constrained model and it's the inherent inflexibility from it. And I think that there's a misunderstanding of what manufacturing is and can do. I think people have very unnuanced understandings of it. So they like that it's all about the idea, oh, we're going to make homes like cars in a factory, right? But actually, I think if you went to
That's the
Toyota,
classic line.
and if you said to Toyota, I want to produce homes, right, at scale, I don't think they would build a factory. They would do what we do because they're all about lean, just in time, all that stuff. And they would say, no, we're not going to build a factory, you know, because
Yeah.
it doesn't work and it's not got the flexibility. So yeah, so there's there's a lot of kind of constraints there, financial, design, all that stuff. Um, and so we've been kind of like looking at the market for many years. We've been a bit ahead of our time and just doing our thing, building homes, but we've always had our eye on the bigger picture. And we've been kind of waiting for the sector to change in a way, and actually, particularly in terms of labor costs. And actually, we've kind of seen this kind of tipping point really, where what we do has now become much more cost effective, because it's less labor intensive, and actually we see our manufacturing costs be very, very steady, because there's not, the cost of a CNC machine, if anything, is less expensive this year than it was last year, rather than, what we've seen with low skilled labor, which is double in price over 18-month period.
Right.
So
Right.
you've got these kind of weird economic factors in there. And like, so we're paying, we see decorators getting paid 50, 60 grand a year for decorating.
Yeah.
And then we're educating people and getting them to become, architects and various other professions who are getting paid less,
Yeah.
and so the whole everything's kind of turned on its head, and that's the opportunity, I think, for us. Um, so we're now kind of venturing into that world of multi-unit schemes and understanding the needs of the developers and their frustrations. So their frustrations are they're trying to modernize, they want to modernize, but nobody quite knows how to do it yet. So, the whole modular thing, volumetric factory thing, everybody's like, well, that didn't work. Like, what's next? And I think people don't know what's next, is the reality. And the developers who we're speaking to are having a tough time. They're finding it harder to get homes built. They're working with main contractors who are going bust. There's been a lot of main contractors go bust because their business models are not very robust. They've got huge amounts of debt, which they carry with them. Like, the more projects they get, the more debt they carry, which doesn't seem like a very good business model to me. And then they go bust. And it's like, how is that
Yeah.
in anybody's interest? So yeah, everybody's out there looking for solutions, and it's a really exciting time for us. So we're starting to think about, well, okay, great, we've got some really amazing proven technology. How do we scale it up? How do we take this to the next level? How can we use the skills and knowledge that we have to make a difference and start to try and solve some of the problems that are out there?
Yeah, so we face this future where, well, I'm sure many people listening to this already understand we're in a housing crisis. We've already got a backlog of homes, and so currently traditional they can go bust during the project, but then at the same time you've got this new factory based which are also going bust. So, and there was even a government inquiry into all the failure of volumetric
Yeah.
and what they call modular. Um, is that like the core things? The factory method does not work essentially because of this. They almost all have that same line when they seem to go under. It was unforeseen project delays and spiraling costs or debt that they were unable to pay, which is exactly what you talk about, is like the inflexibility, the upfront cost of it, and then the inflexibility if you don't get planning. Unlike cars, you can't just park all your inventory in a car park and wait for the market to come back or whatever it is. With housing, you need to build them,
Yeah,
and that's
it's
been,
incredibly um, unforgiving, I think is the word, because you basically, as soon as that, you've got to book your factory time in advance. So you're quite typically selling
yeah,
factory time like 12 months in advance. So that's a long time. So you got to wait 12 months until your building pops out the other end. During that time, you're going to be building foundations, doing other stuff, getting your infrastructure, civils built. So that's a huge risk. We wouldn't do that. So what we do is we're not going to turn up and build this chassis until the concrete's been poured. Literally, concrete's poured, right, let's go. Let's put the machine on site. And then we'll turn up and we'll staff it and start production. There's no way I would commit like 12 months in advance, because who knows? Maybe we'll find,
yeah,
newts or bats, or some planning condition has changed, or God, who knows? There's literally thousands of variables. So it's, and so the fact that they're so big, you're building these big things out of the factory, and you've got to get them out the door, and they have to go somewhere, and they can only really go onto the building side. They're not designed to sit in a car park wrapped in plastic. So there's real issues if they have to sit any more than a couple of months anywhere. So yeah, it's incredibly challenging, and I've always kind of thought I'm not sure this is the right solution. So,
Yeah.
and actually, even if it was, let's say, even if it was the right solution, it's still only a very small proportion of the market. So 94% of homes are built in a traditional process, site-intensive activities. Um, you're never going to change that massively. We're building 200,000 homes a year in the UK. The majority of that is done on site in a site intensive way. The size of the factories that you need to build to service that market are huge, and it takes 5 years just to build a factory. So it's so slow even just to ramp it up. So even if it was going to be successful, it's only going to be another 15% of the market. You've still got at best 80% of the market that still need servicing. So it's still not a kind of very holistic solution. So we're really interested in
Yeah.
transformation of the sector. How can you transform the whole sector? How can you provide tools that allow people to adopt rather than to completely revolutionize the whole thing and just forget everything you ever learned, because we do have existing labor forces, and we need to use those. We can't just transform everything in one go overnight.
Yeah. Um, Maybe a good one to touch on is like so there's a number of different MMCs, modern methods of construction, if people are unfamiliar with that term. Um, and of course, one of the more like sexy, hyped up ones right now is 3D printing. A lot of people talk to me about 3D printing. Great, we're just going to press print and print a load of houses. We've had some good pub chats on the pros and cons of 3D printing, but let's dissect a little bit. Like, what do you see 3D printing playing a role? How does it compare to something like the FACIT system, a kind of CNC'd or digitally fabricated timber approach? Um,
What do I think? Okay, so 3D printing, I think, is a really interesting technology, and I think we will see it in some form becoming more mainstream. Um, but I'm not sure it's going to be in the kind of form that we're seeing at the moment. So, principal problems that we have to deal with in construction is kind of really boring stuff, right? Mortgages and risk. The industry, the
yeah,
home building sector, is basically built off this giant financial risk modeling transfer process, and it is really, really difficult to bring in fundamentally new ways of doing things, which are whichever way you want to think about it, they're unproven, and like we have to deal with that kind of thing as well because we're working in with innovation and new ways of doing stuff. So the way that we do things is fundamentally we're redesigning process, not product. So the actual building product that we use from a structural perspective, from a building ventilation perspective, from a building science perspective, is standard methodology, tried and tested. And that's how we're able to get warranties and mortgages are on the properties. Because if you can't get a mortgage on a property, you can't sell it. So really, really basic
yeah,
stuff. That's where I think some of the real barriers to adoption are for 3D printing. The fact that it's fundamentally novel in process, in build, in quality, in standards is going to be a huge challenge for adoption. Um, I also think that it's not, what do I think? I think it's not a great solution to some things as well. I think buildings are quite angular most of the time, and it's such a revolutionary kind of way of building. I'm not that sure that the wider public are going to adopt it as easily as we would hope, because the buildings just look fundamentally different, I'm not sure how well that would go at scale. I think there's always going to be interested parties, early adopters who are like, wow, look at these 3D printed houses. They're so cool. They're so different. But is that going to hit the mass market? I'm not sure. I think the other point, other things that I have concerns around are you've just got a lot of, it still doesn't solve a lot of the problems. I think, I have a very personal perspective, I guess, from Facet Homes. Like we've tried to create a digital manufacturing process that's quite broad. That incorporates lots of things: staircases, bathroom box sets, internal walls, load-bearing walls, floors, roofs. I see a lot of limitations with 3D printing where you're just not going to
Yeah,
3D concrete print a roof on a single family house. It's just not practical. So there's limitations to the technology. But I think we will see it coming through. I just don't know yet what it's going to look like. You know, I'd be quite interested to see more people leveraging it for foundations. I don't know why people aren't doing that yet. It seems like quite an obvious kind of application because it's concrete
yeah,
already. Whereas you wouldn't really build a single family house in particular in concrete. You just wouldn't do it. And the concrete is there as a material which is really good at multi-story stuff, at mass stuff that you just wouldn't do in timber, or you kind of can do in timber, but the sizes just become a bit ridiculous. Um, so I'm really interested to see where it goes, and I think hopefully in the future you'll see 3D printing being adopted by facet homes in certain elements. Um, I'm just not quite sure where they are yet. So that's my
yeah.
critical appraisal.
Yeah, I think it's interesting. I mean, there's so much hype around 3D printing and 3D printing companies like Icon and Cobod and things like that. But I keep coming back to like, we right now they're kind of limited to walls, printing in concrete, which is unfortunately not the most sustainable. It is a very long-lasting material, but
Yeah.
it's not the most sustainable material. And it still doesn't solve a lot of your other problems, MEP, carpentry,
Wiring, simple stuff, services. Like if you
wiring,
think about the level of detail that can be
finishes.
achieved, it's quite lumpy.
Yeah, it's always, I think Icon are probably seem to have the
Mm,
smoothest finish.
yeah.
But it's still like that kind of bead finish. Like it's kind of cool now, but some people may not like that. It's you're still innovating in a small space, and I always try and explain to people, there's a whole bunch of stuff. Obviously, there's a lot of kind of what I call sexy stuff that Facet is doing with the machine and a container and a microfactory and all the components, which is super cool. But there's also that stuff behind the scenes, which is a bit more less sexy,
Yeah.
but as or if not more impactful, like
Yeah.
costing or just like you say, can you get a mortgage on it? Can you insure it? And like remotely managing the rest of the building site is really difficult. And I know that recently is a lot of things you've kind of improved on over the last few years, right? That kind of less sexy side, but critical side.
Yeah, I mean, so we've spent, probably our focus over the last 4 years has been primarily on building supporting systems for the delivery of construction as we've grown. So we built some really cool costing systems that can like aggregate live cost data, combining that with 3D geometry from BIM models for super accurate advanced costing. We're costing stuff in advance to an accuracy of 1%, which is like, insane. Um, we've built really, really good like remote management tools as well. So one of the things that we've become really experts in is how do we manage projects all over the place? So we've got sites up in Edinburgh, in Suffolk, in Chichester, in Horsham, in uh, there's a few other places as well. Well, there was one in Highgate that was very convenient.
Here in
Um,
London.
yeah, so they're all over. And like, how do you manage construction at a distance? Because we're all based in London, so we've built like remote management processes. We've wrote kind of image capture processes, all this stuff. So we get this kind of real-time feedback from the site, so we know exactly what's going on all the time, and that we are literally in control of our sites, even though we're not there. So, like the project in Scotland was like probably the biggest house we've ever built, like 440 square meters, 4,600 square foot, and I think the design team and us, I think we only went there like 3 or 4 times. Um,
Yeah.
and that's a huge build. So yeah, it just shows the kind of power of the digital tools that we've built. And then we've built some really cool, like very nerdy software, not software like specification databases and client interfaces. And so we built like the probably the most challenging one we've built is an interface for the design team to put their design information into for specification. So taps and fixtures and finishes and lighting and all that stuff, right? Everything in the house listed out. So it's got to be the design information for the design team. It's got to be have a client interface so the client can see it and approve it. And it's going to be for the procurement team as well, so they can order it, and and also that the site team as well can see what's being ordered and is coming. So you've got this kind of single bunch of data, which traditionally would be architects got a bunch of information, clients got a bunch of information, contractors got another bunch of information, and some guy on the site doesn't know what he's doing. But we combine all of this into a single multi-interface platform. So we build a lot of stuff in Airtable, which is such an awesome tool. I mean, we build databases, product databases, we'll build cost interfaces, schedules, like any number of things, because it's so versatile. Um, and yeah, so that's again just allows us to deliver our homes in the way that we want to. Like we do a lot of software product evaluation. There's lots of construction product software on the market, but none of them have really found fit for purpose when you're working in this a team of completely different people all working in parallel together. They're usually, the software products are usually based on traditional contract where it's like,
Yeah.
good for a builder, all the stuff that's good for an architect.
Yeah, it's there's loads of really key stuff I've seen that you guys have developed, and I like costing down to a few percent is is pretty rare in the construction industry. Maybe let's kind of coming towards the end of the podcast. Let's talk about what we're looking to do. I know you've touched on it a bit before, starting to look more developer facing. I don't know if we can talk about our collaboration with
Yeah.
Tharsus, but we can, yeah, let's maybe speak to them about what we're looking to the
Yeah,
horizon.
so about 2 years ago, we started thinking in the business about how can we scale this up? How can we take what we've done and bring it to a bigger market? Because there's just such inherent advantages to scalable digital technology. And specifically, we're like, right, what's the bottleneck? And the bottleneck is really the small scale capacity of our current manufacturing setup. So we set about designing something that's same principles, so on-site CNC, but with a much larger capacity. And we went through multiple different designs and configurations and all sorts of research into various kind of automation products that are on the market. And eventually we ended up with a kind of concept design, which is um, a bigger tent rather than the kind of small kind of cover that we use at the moment, with a high capacity self-loading, self-unloading CNC machine sitting at the middle of it, and a new kind of arrangement around it that allows us to build higher capacity and build bigger kind of build components which we can crane into place. So we kind of had this design, and I knew it's all like feasible because it's all the existing technologies, but kind of combining them together. And we started going out there to find a partner to see who could build this, who could build and start to create this kind of level of innovation. And we found a company called Tharsus, who are up in the north of England. They're famous for being the technology partner for Ocado. They designed, manufactured, built Ocado's robotic warehouse system, which is like this huge warehouses for supermarket goods. Giant, well, they're like big cube-shaped robots that drop off
Yeah,
bags, and they're completely
they go and
automated.
collect all your food and
Thousands of
stuff.
them going around, and Tharsus do everything. They build the things, they do the fabrication work, they design the control systems, and they're probably one of the few companies in the world who could do everything we need in one package. So we took our concept design to them about 8 months ago, and they have been working on a design to bring it to life. One of the critical things that they've been able to do is integrate our next generation technology as well, which is 2D surface printing. So we're like, we constantly have problems on our building sites of people, we put a lovely digitally manufactured chassis up, but where does the socket go? Where does the backset go? Where's the tile setting out mark?
Yeah.
And constantly everything is in the wrong place, right? And we're having to quality control it and make sure it's right. So what we're designing is a system that uses cardboard packaging printing, like large format printing onto the surface of our plywood before it's cut. So we get all of that lovely design information onto the surface of the components. And so Tharsus have been designing and integrating that print system taken from a different sector into our automatic loading system that they've designed, and the unloading and the buffer, and they've created a beautiful design and prototype so far for this high capacity machine. So that will give us capacity to do 80 homes per setup per annum. So really a high capacity for housing. And we're now out there talking to house builders and developers and saying, right, how do we get this going? And we're kind of in the early stages of looking at pilot schemes and trying to kind of get this thing up and running so we can prove it at scale.
Yeah, unfortunately, we can't unveil the machine yet, right? But well,
Yeah.
we'll see. But but it's a pretty cool looking thing. Um, but yeah, it adds a lot of that automation, right? Material on, material off. The 2D printing, I think, is a really great example of. I mean, I'm calling it like low tech, high tech. It's actually like it's a really low tech solution in that like here's instructions: do not drill here or put a light switch here. But there's a lot of that intelligence is kind of the high tech side is in the digital
Yeah.
side. Like how do you pull that out of the Revit model
It's
and
quite challenging from a design and
nest
implementation
it?
perspective.
Yeah, which is really the philosophy, right? Absorbing the complexity
Yeah.
digitally to make the assembly simplified. So yeah, it's exciting times
Yeah.
ahead, and we're in that process of scaling this up and hopefully build a few more homes in the next few years.
Absolutely.
All right, we'll wrap up with our last question that we ask all our guests, which is 2024. There's a lot going on. There's the rise of AI. I mean, we didn't even talk about AI actually, but the rise of AI. We've got game engines. We've got new headsets, 3D printing, digital fabrication, all these things. There's so much going on. Is there anything that you're particularly excited about
Yeah,
on the horizon?
I think I'm most excited about the new generation of augmented reality tools, be that a headset, be that VR, be that photogrammetry. Like there's some really interesting stuff coming through, and it's what I'm really interested in is the application of this technology at the construction site, at the point of construction, right? So we've seen over the past few years a lot of people doing point cloud scans and stuff for trying to do analysis, but it's very retrospective. It's like, great, I've done a point cloud scan. It tells me that that's built wrong. You know, it's too late. It's built wrong, right? How can we use technology to build things correctly in the first place rather than tell us it's built wrong? So I think the some of the tools that are coming on are super exciting, and I can't wait to get our hands on it and just really test it. I think we're in quite a privileged position because we have this really accurate BIM model and components that are built from the BIM,
Yeah,
right? So that means we're one of the few companies who can really leverage that. Whereas if your BIM model's a bit chunky, it's not going to work so well.
yeah. No, exciting stuff. And I think we've also got our own sites to test these things on,
Exactly.
which is a key thing. Well, I think we'll wrap it up there,
Awesome.
Bruce. That's a lot for people to
Yeah.
digest, a lot of interesting stuff. And thank you for coming
Thank you
on
for
the
having me.
podcast. We'll be back next month with another episode. We'll see if we continue down the road of digital fabrication, or we've done a lot on AI, Bruce, recently. So we'll see where we go. But thank you for joining, and we'll see you guys in the next episode.
See you later.
Cheers.